So this simulation does look quite promising, so let's crank up the resolution on this and cache it out. So back on this whitewater solver, I'm going to set this whitewater scale to half of what it currently is, and reducing the particle separation like this is really going to crank up the resolution quite a bit, and we'll wind up with many more particles. So I'm not going to try to flipbook this as I cache it out. Let's just create a DOP import, and set this to fetch geometry from the DOP network, drag the DOP network into this DOP network parameter, and for the object mask, I'll type in whitewater star, so this will bring in any object prefixed with whitewater. So if you display this DOP import, you can see this is currently bringing in all the points here. And if you want to make your cache a bit more lightweight, you can get rid of some of this information here. I don't think we'll need any of these groups. We shouldn't need any of these detail attributes either. Not that those will really take up much data, but it should be safe to clean those up. And we won't need this primitive attribute DOP object either. But these point attributes could be quite handy later. I didn't render the bubble and foam and spray particles any different from each other. They're all just partially transparent particles, but I will leave that data in there in case we do decide we want to treat them different later. So I'll drop in an attribute rename, and on the primitive tab, I'll get rid of that star, and get rid of the star in the detail tab as well, and drop in a group delete, and put a star under group names to delete all of them. So this cleans up our results a bit. So now let's cache this out. We'll drop in a new file cache. Let's point this to the river directory, and I'll make a new directory called closeup whitewater.vo1, and set the file name to closeup whitewater.f3.bgo.sc. And for the close-up shot, we don't need to simulate all 240 frames. My close-up shot only goes up through frame 100, so I'll set that range accordingly, and turn on load from disk. I'll rename this to cache whitewater, and then save this high-resolution sim to disk. Now this high-resolution sim is all finished caching. This frame has almost 2.4 million points, and now let's see how this looks in the actual render camera in context with the actual river mesh. So if we go back to the render camera, we're not currently going to see our whitewater points because those are still at simulation scale. So let's drop in a transform, call this sim scale invert. And because everything we've been doing in this setup has been at simulation scale already, we don't have an existing transform to reference for the scale. So if you don't remember what simulation scale you're working at, you can go back to the simulation setup for your river close-up flip sim to check the value you're using there, which you can reference directly if you want. But I'm just going to manually set this transform to a uniform scale of 0.2, and then turn on invert transformation. Then display that transform, and now you can see all of these whitewater points are transformed back into our rendering space. And let's flip our viewport to show all objects. And let's also import the river close-up mesh for visual reference. And if we want it to look a bit nicer in the viewport, we can grab the color visualization version with that color based on velocity. So I'll pin my viewport to whitewater close-up here so that it doesn't update when we go to that river close-up setup. So jumping over to river close-up, we have this colorized version of the mesh down here, which I'm going to connect to the sim scale inversion, so that's in rendering space. And I'll drop in a null and call this out meshed with color. And back to the whitewater setup, and let's object merge that in. So I'll point this object merge to object / river closeup / out meshed with color, and put our template display on that object merge. So this will allow us to see how this whitewater looks in context with that actual liquid sim. And we can also apply some color and alpha to these points to make them display a bit more nicely in the viewport. So I'll drop in a color sop. I'll just leave this on its default color of white. And then to set the alpha, you could do this in a wrangle if you'd like, but I'm going to use an attribute just float. And then set this attribute name to alpha. and this has to be capitalized alpha. And all our whitewater particles are now invisible because their alpha value is being set to 0. But if you start to raise that value of that alpha, then you can see these particles are now appearing partially transparent. And the display of the transparency in the viewport here isn't very reliable in terms of matching how it looks in the actual rendered image. So don't worry too much about getting your alpha value perfect for display purposes. You're going to need to change this value once we see how it looks in the actual renders. But for our temporary flipbooks, setting a value of 0.1 seems like it should work reasonably well. I should also point out that the size of the particles in the viewport display isn't reliable either. The size of these is just driven by the point display setting. So if you hover over the viewport and hit D, then under the geometry tab, you can see that we have a point size setting here. So this is just a uniform screen space size for all the points. This doesn't take the p-scale of the points into account at all. So at a larger point size, the whitewater looks really overwhelming, and with the point size set quite low, this whitewater is looking fairly minimal. So this really highlights why we have to start rendering things properly in order to judge how our simulation is looking. And speaking of rendering, we might as well go ahead and set up a render null and call this render whitewater. And now let's run this flipbook with everything displayed nicely. Now the beginning of our flipbook doesn't look right because we don't have any render mesh cached out for the water prior to the start frame of the shot. So I'm just going to change the flipbook start to start at frame 15. And now everything is looking pretty cool. I'm happy with how the results are looking so far, so we can go ahead and start rendering this. If I'm being picky, there are a couple little spots that I don't really like the behavior of. For example, the way these whitewater particles are kind of shooting out here doesn't look very nice to me, at least in this viewport. We can wait until we render this to decide if we want to keep that area or not. But if you want to remove this little bit of emission in that spot, you can of course delete this region from the extra whitewater sources, similar to how we did the trim on the side of this rock that's facing into the current. So you can certainly feel free to art direct some of the emission areas to your liking, but overall this is looking quite cool, so we can go ahead and start rendering this.